In this video, we're going to do an overview of the Git technology. Git is a distributed version control technology. It's a fancy word of saying a way in which we can share source code and other files, usually across development teams. Git is a technology that's used by several different vendors. GitHub is a company that provides a front-end interface and hosting services for the Git technology. Oftentimes, there's some confusion over Git and GitHub being the same thing, and that's not actually true. There are numerous vendors for providing an interface to Git technology, so it's important to remember that Git technology is the underlying system that allows us to share source code, while GitHub is a provider of services that allows us to have access to those files that are stored in a cloud-based system. There are other systems, not just GitHub, such as Bitbucket, TFS, and some others. One of the first things to understand about Git is a repository. And that's really just a location where you store files for a project. A local repository is going to be on your local hard drive, which is where you're probably used to having your files stored when you create a project in an editor like Eclipse. In Git technology, remote repositories are a copy of your project that are out on a remote computer, a server, or the cloud-based system. One of the key terms in using Git is the word collaborator. You'll see this word used in a lot of the software, which is just a reference to people that you're working with on your project. So a collaborator's repository is a copy of the project on their computer. And you could have, this could be in a pair programming where you're working with one other person, or a team programming scenario where there potentially is many people working on the same project, all of whom have their own repositories, and it's a copy of the remote. So on the screen we have a sort of a scenario just to show, kind of give a visualization of how this works. Down the center we have a public repository, which is an open source project, and these are just examples, and maybe a private repository, which is maybe a website project, and then another private repository, which is maybe a school project. And we have three people, Michelle, Yvette, and Fred, and as they set up their computers, they're connecting to these repositories, which exist in this example, maybe in GitHub. So here Fred has connected to the private repository that's the school project. Yvette and Michelle have both connected to the same private repository, which is a website project, and then all three have connected to the open source project. Over here on the left, Michelle has Git installed, and she ends up with two local repositories, one for the open source project and one for the website project. And these are copies of the projects on her computer. Fred also does the same thing. He installs Git and sets that up and ends up with, again, two local repositories. And you'll notice that his are different because he has a school project, and then he's also a member of the team on the open source project. And Yvette does the same thing. Now hers end up looking just like Michelle's because the two of them are both working on the same two projects. Once these developers have installed the software, the Git technology, and they have access to the vendor, and in our example GitHub, then they do what's called a clone. So in the center, we'll just use the website project as an example. Maybe there's a whole bunch of files, and those files are stored in that cloud-based system. Michelle does a clone, which brings the website project, a copy of it, to her computer. She ends up with that local repository, and at that moment she has a duplicate of whatever the state of that website project was on that cloud server at that moment. Yvette does the same thing. She ends up with her own copy of the website project and ends up with a duplicate. So if this were to happen all at the same time, then all three of those repositories would have duplicates of the files. Over time, as they're working on the project, they do what's called push and pull operations. Michelle does a pull, which brings any changes that exist in the repository on the server to her computer. So she gets a copy of any updates or changes that may have been made by someone else. Yvette does the same thing. So they're keeping their local copies up to date as they do this. You notice in Michelle's copy, she makes a change to the main.java as an example, and then Yvette makes a change to the same file. Those two changes are different though, different lines of code or different portions of that file. When Michelle pushes those changes to the server, then the server receives that update and its copy now has the changes that Michelle made. Yvette does the same thing. She pushes her changes. Her changes are now part of the centralized repository as well. And then those changes can be merged into the master files that exist in that particular repository in this website project as an example. Now this was an example of two developers making changes which do not conflict with each other. So they were adding maybe some additional lines of code or changing existing ones, but their changes didn't affect each other. One of the other possibilities is that they make changes to the same lines of code, which actually turns into what's called a merge conflict. So as an example, same scenario, Michelle pulls the project, Yvette pulls the project. They both make changes and push those changes. We're simulating to the same lines here. And so in this central repository for the website project, we now have a conflict. That same line was changed by two developers. And that's referred to as a merge conflict. There's a notification that occurs when a merge is attempted. The last person to push their changes are notified, and it's up to them to initiate a resolution. Now that may be changing their code, communicating with the other developer. There's a number of possibilities and ways in which we resolve conflicts with merges. In Git technology, we don't have a term that we're used to hearing when we're working with files, and that is save. In Microsoft Word, you've made your changes and you want to make sure that those are kept. You use the save command. In Git technology, we don't have that word. And the reason is because save historically means save the changes that I have made right now. And generally that also means that whatever state the document was in, again, let's use Microsoft Word as an example, I write some paragraphs, I save that, I come back the next day, and I make some new changes, and I hit save. My copy of that file from yesterday is overwritten. And that's historically how save works. In Git technology, one of the key elements of source code control is keeping all changes that are made historically. And so I can always fall back and revert back to any state of my software development that I need to. And that means that all changes that have been made are committed to the system, but they don't overwrite each other. So all versions of the files are kept over time. Another concept in Git technology is what's called branches. So there's a main branch that we maintain, and that's considered the most up-to-date live copy or production level copy of the software over time. As programmers take on a new project, they want to add a new feature to the software, they need to make some significant changes to the way the functionality works or something like that. Instead of working off of that main copy of the software, they branch a copy of that off, and often refer to that as a feature branch or a fix branch or something like that. And that programmer can work on that branch. They have their own copy of it, and this is actually stored also on the server, and they can work on that over time because often software development takes hours, days, weeks to work on a particular piece. And so a programmer could be working on that while another programmer has a branch of their own. When they finish that work, they merge that branch back into the main, and it becomes part of the production level software. And that's, of course, after completion and testing and those kind of things. Earlier we talked about a pull, and the concept of a pull is that I'm making a copy of all changes that exist on the server at that moment. Another approach is what's called fetch, and a fetch is it refreshes my local repository. It indicates to me whether or not there are actually changes on the server that I don't know about yet. The difference is that it does not actually commit those changes to my local branch. It's just basically a notification. It allows me to see, oh, there are some changes, and I can see what those are, and I can decide at that time whether I actually want those in my copy or not. And there's times when, if I'm working on a feature and I want to not have any new changes overwrite maybe what I have in my local repository, even though I'm keeping all changes historical, there are times when I want to finish what I'm working on before I get an update from the server, and I can use fetch to do that. Now, Git Technology has a great deal more to it than what this presentation talks about. There's a large number of vendors, as mentioned up front. GitHub is currently the most widely used. There is a Github Web Interface at github.com. There's also a GitHub desktop application you can download and use that, both of which helps you manage your remote repositories. Git Technology is also integrated into most integrated development environments, Eclipse, IntelliJ, NetBeans, and there are many others where you can interact with your Git repositories directly in your editor. In addition, there's also graphic user interfaces. There are third-party products that allow you to work with repositories similar to the GitHub desktop, but they're provided by other companies or other projects, most of which are open source and available to be used for free. And then also Git Technology has a very abundant command line version of interacting that is quite powerful. It takes a fair amount of time to learn, but is often used by advanced developers to manage the repositories in a very precise manner. In order to install the Git Technology, go to git-scm.com, and it's available for all operating systems. And then GitHub is github.com, where you can sign up and create an account. And as a student, you can have a free account where you can learn the GitHub technology and interact with others while you're learning how this works. If you have any questions, feel free to contact me, and thanks for listening.